Yo, 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 good morning, happy Friday, etc. Yo, what's up, Derek? Um, okay, so we're gonna continue with the tessellation today. Um, did have... So yesterday we focused on two things. We focused on fixing the seams between tessellation patches, which, after some knowledge gaining and analyzing, was pretty straightforward. We fixed that in one go. But what came thereafter was a little bit more complicated. Let me explain. So right now we do tessellation only based on distance from camera. We're going to add some a few things more later on, but right now it's only distance from camera. So when we get closer to an object, this object for instance, it's going to tessellate more. It's going to subdivide each of these original quads into subquads. We have put such a constraint on the tessellation, partly by doing it with quads and partly by doing it with 2 to the power of x, which means that a vertex that exists at one subdivision level will exist on the next one as well, with the exact same position. So this means that the only thing we do when we subdivide more is we add additional vertices. We don't move any of the current ones around or anything like that. So if that holds true, that means that we can pretty much figure out the age of a vertex, or like when did this vertex spawn. And if we know that, then we can adjust the height of them later on when we do displacement, so that instead of popping when you move closer to a terrain, it slowly fades in. And that's what we're going to do today. The first thing, if we want to do that, however, is to be able to identify which are the new vertices. And that is what I spent the way too much time on yesterday. At the end of the stream, I didn't have it down 100%. We had points at the lines between quads still weren't being marked correctly. But as soon as I quit the stream, I figured out what I have been doing wrong. So first we tried to do it in a very nice way. Let's see if I can find it here. First we tried to do it in a very nice way, so that each vertex, the same function is applied to each vertex. We don't have any branching or anything like that. At the end of the stream I said fuck it and try to implement a branching. So pretty much identify the edge vertices, handle them specifically. The only thing I did wrong at the end of last stream was that I did, if UVY is equal to 0, Y tessellation factor is equal to. Y tessellation factor is equal to. But it's like when the YUV is 0 or 1, we want to handle the X specifically. And that was the only thing wrong I did at the end. So right now we have something like this. White means that the vertex has already existed. And if we move on, we can see here that this one is still white, this as well. But the new vertices here, here, and here are marked as 0. And if we go even further, we can see that it turns like this. Although I wonder if we have... I think we're good. So this one is new here and it gets marked accordingly. Old, 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 old. And then as we move closer, we get something like this. So this is a little bit of a worst case scenario, but it still works. So all of these are new. This one as well, still. But then if we move closer, and here we get this. So yeah, we get a nice pattern, white vertices, old, black vertices, new. And it pretty much works up to the max amount of subdivision we can do. Yes, it does. So what I want to do now is I want to fade these black vertices, so the vertices that are marked as black, I want to fade those such that the closer they are to being tessellated, the more we fade them to white. And that is going to be the height adjuster. So we're going to calculate a position that is, so pretty much the proper position, and then we're going to calculate neighboring positions. But we can do that in a very unoptimized way. So we're probably going to implement it like that, the unoptimized way. We're going to do a lot of extra calculations, but then we're going to hide it behind a graphics fidelity setting. So if we go with the highest graphics, that's when we do fading instead of popping. And then we can probably find some middle ground as well. But yeah, this is very nice. So in this case, I reckon that, let's see, we can go down. So here we have this one as black and this one as black. If we move one closer, they're going to become more white. These ones are still going to be stuck as more black. Even more white, even more white, even more white, even more white. And then when we do this. Virtual 2, hello. What's up, by the way? Good morning. Do you know when you are going to do a new devlog? I'm working on one right now. It's going to be, I'm going to go through some simple stuff first, just to get back on video devlogging. But hopefully I will have it out in March. And it's going to be just a quick run through how I did the animator. And then I'm going to do how I did the simple stuff of the apparel, which will hopefully be out in April, and then I'm gonna do some devlogs on terrain. But to answer your question, hopefully this March, unless something very unforeseen happens. Okay, so let's begin. What we output is this pretty much. So we calculate a UV, or we get the UV for the vertex, and then we calculate a compare value in X and a compare value in Y. If it's if we can't do modulus and get 0, then we know that we're in a step that is newly generated. Yo, what's up, Cooler SK? So now we just have to figure out. So for instance, if we have a subdivision of a tessellation factor of 8, so each UV is at a 0.125 step, then our compare value is 0.25. So for every other vertex, this will not be 0. And I think we want to take whatever value we get here and then compare it to whatever world position we have here, I reckon. So we can try something. Let's get Guten Morgen. That's German, right? So I wonder if it's as easy as this. Let's see. We're gonna do float diff is equal to min max uv.x x compare value uv.y y compare value, and then we want to do we pretty much want to do diff I wonder if we want to do we also want to calculate current diff is equal to calculate. I would like to use this one, but I don't care too much about this one, because if we do the power to 2, we're still gonna get 2 to the power. We're still gonna get truncated values, I think. Unless we skip the round here, actually. That is true. So let's take this one right now and do... Yeah, let's keep it here, actually. View vector, position world space. So we get the vector between camera and the position world space for this vertex. We calculate the distance, then we do inverse lerp, and we do 1 minus, and then we do lerp without the round. And float current diff. I also want to do, I think I want to do 1 divided. So for this specific vertex, we calculate the exact subdivision we should have at this one. So if this one would be 4, we might be getting 3.2 to the power 2, 1 divided by, so then we know the step of it. Yo, what's up, Geralt? Good morning. Happy Friday. Happy Friday. So I wonder what value we can get here. Let's pull up the calculator. 1 divided by 4, yeah, 0.25, but we could get 1 divided by 4.2, 23. Basically, I want to figure out I wonder if we can do this. If diff is equal to we can start by doing a branch here. So if diff is equal to 0.0, then we return 1.0. Otherwise, we return abs of diff minus current diff. Wonder what this will yield. So diff is more like, how should I explain these? Diff is what we currently have for, or it's based on the current tessellation or subdivision amount, while current diff, bad name, is the subdivision amount this this point should have. Let's see what this yields. Position center vs, and then we can go from there. I think we're going in the wrong direction. Apart from that, I think we're good. And I think we want to do divided by diff here as well. But we're moving in the wrong direction. Not really. Yeah, we probably want to do diff current diff. Actually, I just want to do a inverse lerp 0, 1 between diff and 0.0. I would like... Yeah, we're still getting too bright here, too bright vertices here, because we would be getting, like right here, we would be getting popping for these. Sasanidas, what's up? What are you making? We're making a tessellation shade right now, which is going to be used for a hell of a lot of different stuff, but for this stream, mostly for snow. But we're probably going to use it for the terrain, the water, everything in the environment, I would say. So if we take a look at this black triangle here, or these vertices, here we would get some beautiful fading. You see? And then if we move even closer, so we would fade it up. What I hate though is this step right here. We're getting popping here. Even though we wouldn't zoom in at this step, we would still be getting popping here. So the vertices that has a gradient of gray, they are new vertices. The gradient explains or tells us how new they are, and these are marked as a little bit newer than they are. They should be pure black here, pretty much. So the way we calculate this is, what this tells me is that we can't rely on current diff. Current diff is too... it's not conservative enough. Pretty much. And this is probably because if we take a look at these points, we can take a look at this point right here. It's based on like this point and this point is extremely close to the camera, right? So they are going to be subdivided before our middle point of the edge is being subdivided. So our middle point is around here. Fuck, how can we solve this? Yeah, look at this one as well. This one would yield... Actually, this one is fine. Except for these. So if we take this point, for instance, it will get the maximum subdivision amount. Or this one, it is. I wonder if we want to do a... If we want to do the damn... yeah, when we calculate the current diff, we don't want to do it from this point. Instead, we want to do a bilinear interpolation and take the subdivision here, 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 and here. I think that's how we want to do it. So current diff. So this is way 1. Let's do util math, interpolate by linear. So 2, interpolate by linear float, f1, float 2, float f2, float f3, float f4, and float 2uv. And then we do return lerp f1 to uv.x, lerp f2, f3, f4, uv.x, and uv.y. I think this is how we want to do it. We just have to be real careful how we send in the values, in what order we send in the values, but it should be pretty straightforward. So we can do float current diff is equal to bilinear, interpolate bilinear, and we do okay, if I remember correctly, this is a little bit, our quads is a little bit weird. I think we have x up here and y like this during the interpolation stages. We can double check that one real quick. We can do output.test is equal to uv.x. Oh no. x0, x1, and like this. Okay, so when we interpolate this, or when we do the current diff, we should go although I'm not entirely sure if I'm doing this correctly, we might just, yeah, we take the x coordinate and lerp between edge 0 and edge 2, and then we take the y coordinate and lerp between E1 and E3. Which gives us 2 values though. Shit, how do we want to do this one? And then we might actually just take the minimum of those. So yeah, let's do that. let's do it like this. Current diff, minimum of, is it minimum or maximum? We will find out. Lerp. So let's go with this one first. What do we have? Factors dot edge 0, factors dot edge 2, and uv dot x. And lerp factors dot edge 1, 3, uv dot y. Something like this. This feels wrong. There we go. Yo, what's up, V0? Man, this is way over my head. If you stick around, it might not be at the end. So instead of calculating the subdivision amount per vertex, we interpolate it from neighboring edges. What's up, Catboy King? And let's see what kind of result we get with this current diff instead of the previous one. We get nothing. Okay, this is not good. Oh, yes. Current diff, we need to subdivide, oh, we need to divide this by so what we're getting here is factors that are 2, 4, 8, 16, 32, and on and on. What we want is a value that is between 0 and 1, and so we pretty much want this one. We want 1 divided by this one. So this should yield a better result. I'm not sure if it's the correct one though. Maybe it is. It's still too light here. Yeah, we're still getting too bright values. And that fucking sucks. Cooler SK, I've been here a few years, still have no idea what's in the water happening. Other than water. Yeah, it's mostly about water in these streams. In all different states, actually. Gas, fluid, solid. I know what min and abs do. That's a start. Okay, I should get my own... what are they called, Catboy King? Emotes, some water emotes on this channel going. Okay, but like even though we do it like this, we still get the wrong stuff. This one is, they are too bright here. So what I want to see happen here, when we subdivide this one, I want the new vertices to be pure black. So this one, and this one should be pure black. And then when we move closer now, they should fade to white slowly but surely. What am I missing? And if we do max here, we get Okay, if we can't calculate the current diff like this, what the hell can we do? What can we do? It bothers me that we also get... We might need to take the inside into account as well, and then it becomes very complicated. We definitely want this age to depend on camera, distance to camera. But then we also need to constrain it or transform it based on neighboring edges subdivision amount. Fucking hell. So we had a pretty good result with this one, I reckon. But it was a bit too bright. So this is the best one yet. But when we pop these in, they are a little bit too bright, right? Just a tiny, tiny bit. Saturate. Or I guess we could actually do it like this. This point. So the point we use right now, so for this one, we use this point. But I guess we would like to use whatever edge is closest. But if we use this one, so we get the position of this one instead. Would that help? And because this one is still subdivided, yeah, it would probably be white then. One sec. Back, sorry about that. Let's see. Like this looks beautiful, I would say. But the problem is when we get this. We get the tessellation when, not only when one edge gets tessellated, but two, at least two has to. And then we have a set of points that should already be tessellated. This one worries me a bit as well. Because at this point, this one pops from almost white to pure white. So that gives us a tiny bit of popping as well. But it might be so little that it's not going to be visible. Yeah, I'm much more worried about this. So this one. Have enough values available to us to solve this. I guess we can do... Can we do it like this? If we can calculate if the point in question is I was thinking closer to the camera than this or this, then use this or this value. But to do that, we're gonna need to, because that's pretty much the problem we have. Yeah, 100%. So this one is further away, and we get pure black here. This one and this one are the closest. These are closer than this or this, which means that this one will be brighter. It always depends. If we take a look at this one as well. Yeah, here we probably want to mark these based on this one. Is that actually how we want to do it? If so, actually, I don't know why this... Let's take a look at this one again. Current diff. Probably don't want to do max here. Let's do some drawing. So in this case, if we have the camera roughly here, we might be getting 8, 8, 4, 4. Which means that when we take this point and interpolate these values, we interpolate on x between here and here. The value will always be between 4 and 8. We will never go outside of those bounds. But this one might actually get 7.2 maybe. 7.2. Which means that it is pretty new, just not new enough. 1 divided by 1, 2, by 8, and then 1 divided by 7.2, 0.13, 8. And then we do the difference here. Which leaves at 0.0 0, what is it? 5813. And then we do divided by 0.125. But then if we have a point right here, probably gonna get even more. Yeah, we can see here that Yes, and then if we work with, when we get to the fully one, min and max is got, yeah. This is a hard problem to solve. Just want to add this back, see if it gives me... on. It's when this one makes me wonder. We do max. We do max or min here. We do max. So it's probably this one. When we start subdividing this one, we subdivide them all. When we calculate dispositions later on, we need to use this one, this one, this one, this one, and that works. We just have to, in some ways, we need to calculate the age between and it should have a value between 0 and 1. Currently, we can calculate the age between... Currently, we can do it, but some of them get a higher age than they should, because they are actually closer to the camera than whatever is controlling them. But can that be fixed? Yo, good morning, Harukanan. And welcome back to this shit show. Good news. We managed to solve the seams, and now we're focusing on specifically calculating these black vertices, the age of them. That is what we're trying to do. Without much progress right now, unfortunately. I wonder This one, for instance, right here, it should be, here it should be pure black, and then as closer we get, it should be wider and wider and wider. And right about here, it should be pure white for this one. But then again, and the same goes for this and this. Fuck, this is hard. Could we... The problem here being, or the biggest problem, that this point is closer to the camera than this point, and those 2 points are actually the ones controlling the tessellation for the patch. We have the middle, the inside ones controlling it as well, though. Which makes me wonder, I guess we could just take the full patch, or the point furthest away, and do this check, but that would lead, we would get good fading here. Except for the edges, but I guess we can handle them as well. With the branching. The more I think about it, this makes sense. I.e., use the UVs, get the closest subdivision basically. Then we want to do it closer we get to, okay. If we calculate to if we don't care about the edges right now, we just care about the inside. Could we do problem is that these are always, or in some cases, they're going to be closer to the camera than these. It's like the fourth time I repeat that because it's that fact that screws up the initial solution I had in mind for this. So at this point, this edge and this edge changes tessellation amount. Not this and this just yet. Go. Play. Min here. No matter how many times I look at this, it's not becoming any clearer. So right at this moment, we want the age of this one, and this one to be 0. Then it's gonna grow, 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 grow. And right about here, we want this one to be white. These should also be whiter. So right about here, this should be blackish. No, no, no. Here it should be white. Here it should be, let's see. Here it should be white as well, but then darker, darker, darker. Are we gonna have to calculate? Well, let's put it like this. We can probably solve this by branching as well. So like, it's almost always pretty much the full quad changes at once. Right. We have the problem with the edges though, but if we don't care about the edges for now, it It always changes at once. I'm wondering if we're doing ourselves a disservice by sending down... Like, we want to tessellate it x to the power of 2, but I'm wondering if whatever value we return from here without the round is actually something we want to keep around. No idea. So like if we want to calculate this value here, keep track of min and max. Keep track of min and max. Interpolate. Don't think that will help us, however. But it is the constraints we have added that makes this problem a little bit harder. If we would have had a subdivision that is floating pretty much, so instead of going 2, 4, 8, we go 2, 3, 4, 5, 6, 7, 8. We might get some more information. We could get... Ooh. We base it on the middle point of the quad, or if we calculate that value, the subdivision there. So this one, that was the best. Except for these points. And then, of course, when we get to... This one definitely works the best, I would say. This one is still rough, though. we take... I always want to fall back to the closest edge, although I don't think that will help us. It's pretty much like this. So this is what it is. We need to get the two closest edges. So for this point, we get this edge and we get this edge. If and then we check which one of those are furthest away from the camera. And then we base the gradient on whatever result we get there. So how close are we to getting to the next subdivision for that edge? I think that would solve the problem. So here, for instance, we take this point, we get this edge and this edge. Is this or this closest to the camera? This one is closest to the camera. Or actually, maybe we should take the one that is furthest away from the camera. So this one is far away from getting subdivided, hence this point is far away from getting subdivided. Now a bit closer, a bit closer. This one is probably already subdivided. Or extremely close to. And this is where this one subdivides, but not this one just yet, I don't think. Do we do max 0201. We do it per point. We calculate this subdivision, this subdivision, this subdivision, this subdivision. And then to calculate this one, we take the max of this one and this one. Okay. But we only have the edges. We want to fetch the closest edge point then. Oh, so when we get closer to this one, we subdivide. So If we take this point, we get the closest we get all the corner points. Let's see here. If we want to get the closest corner point, let's start with the simple one. We start with this point. We get the closest corner point. It's this one. So then we base the color of this one to how close this one is to getting subdivided to the next level. So here we have just subdivided this one, hence this is pure black. More white, more white, more white, more white, more white. And then when we get to about here, this one is still pure white. But as for this one, how would that case be handled? This one's closest point is this one. This one is still far from getting subdivided. So this one would still be black. But what would this one be in this case? Closest point. Yeah, here we subdivide this one. Although I wonder... It's just... So the points laying for... This is true for all points on the plane. They always depend on the closest corner point to the camera. Except the points on the edges. So that's special case. Okay. So during the tessellation, we can probably set which point is closest to the camera. And then we know the amount. We can start by doing that. Actually, it should be pretty straightforward. And then we will see how we handle these edge cases. So now we currently have quite a lot of branching and stuff, which I'm not that fond of in the shader. But if we just make it work, hopefully we can gather some more knowledge, and then we can see if we can refine it. But we definitely depend on the closest one. If we move away... Yeah. Except for these edge points, though, they depend on that edge. Do I want to do... Let's start by doing this. Let's get the point that is closest to getting subdivided. And then we base a float value on that one. Let's see. So for each point we do calculate tessellation amount. Unfortunately, we do round here, which we don't want to do this time around. And it's basically Whatever point that returns the biggest t here, I think we can probably just take the not the t. We want to get the error round. Calculate tessellation amount. Let's return Yeah, we pretty much want to calculate this. And then we want to take the rounding error here. Would it be easier if we don't do round, instead we do floor? If we do floor, and then we take the pre-floor value minus floor. Let's see what happens if we output that. So let's do float. Let's just call it progress. And progress, and then we set so basically what we would like to do here is calculate tessellation Okay, we can probably do it like this. Calculate tessellation T. So we just return this one here. Turn. And now we do calculate tessellation amount, float T. Do we do here? Tessellation amount, what do we have here? One sec though. Okay, so I wonder if we want to do this. We calculate them like this. We change this one to... I'm a little bit worried about, let's take a look. Load. Okay, great. Calculate tessellation T. And then we do... we have float here. Float progress is equal to max. One, two, three. There's still a question of how we will handle the edges, which I'm not that fond of. But okay, here we get the biggest T. And then we do... this, and we do... calculate tessellation amount. Something like that. And finally, we want to calculate output.progress is equal to... what do we have here right now? We have a T. So we pretty much want to do... progress is equal to... this one, except for this. And let's change this down to floor. And we do this. And basically what we want to do this then is progress minus floor progress. which should be a value between 0 and 1. The bigger it is, the closer we are to tessellating. Maybe. We're not going to do anything different right now. I just want to see how this looks. Tessellation amounts. Undeclared identified T. Yes. So this is the progress, right? Okay, we still have this. That's great. Now let's see what happens if we output. So if diff is equal to 0, we output 0. Otherwise, we output input.progress. Not input, but factors. Progress. I think it's black enough, but that could also be... here it's black enough. Now we get closer. How did it work here, actually? Yeah, we can see we have a little bit of a difference here because we don't handle the edges just yet. I think it's the worst it is here. But then when we get closer, it becomes whiter and whiter. Right up to... And then we have this. And if we move slower... Pure black. The only problem we have is the fact that we don't handle these very good. The easiest way to do this would probably be just include them here. We use a different factor here. It's still not... I think this is pretty great. Progress. Can we interpolate the progress? This looks pretty damn nice, actually. Except for this shit. If we store progress per edge or per point, I think we could actually, if we store the progress per these vertices, and so bum 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 bum. Now it's just a question of how do we do this in a nice way, because if we like, does it exist a simple but nice way to handle these ones? Let's do it the ugly way. I think we can do it like this. Tessellation amounts. Let's just do per edge. We basically want to store yeah, we basically want to store a progress per edge. I'm just thinking about where I want to do it, where we want to do the 2 to the power of. Gonna have to do it in here. And then it's very important that, so progress goes between 0 and 1, between the current subdivision amount and how close it is to reach the next subdivision amount. So it's related to what I'm trying to say is that you might have an edge that has progress 0.5 and another edge that has progress 0.5, but they are related to 2 different values, or a set of different values. So we would probably want to do it after we have done the max, which sucks, but we can probably do the max. Calculate tessellation T. We can probably do max or min here, I reckon. Couldn't we? I think so. But that means that we're gonna do 6 calculate tessellation amounts instead of just 4. That also means that we can skip this one. Actually, we only need to do max on these 2, don't we? Just gonna focus on max, the max solution right now. So if we do fuck it, let's go a little bit crazy. Calculate distance. No. This one we don't use, right? Calculate tessellation T. Calculate tessellation amount. Float. Truncate. Thinking of splitting this one up into this. Calculate tessellation amount. This. So then I guess we can do calculate tessellation T. Now in that case we can do let's do calculate tessellation amount, return, so T is equal to calculate tessellation amount. We do this. So this gives a tessellation amount between 0 and tessellation max amount. I'm wondering if we can just stick it in these instantly. No, we cannot. And then we do this. But this is per point. We want to get the progress per... Oh, it's gonna be ugly, but whatever. Finally, what we need to do is last thing we're gonna do is see. We want to do that. We don't want to do that. Finally, we want to do pow to output.edge. Let's do 0. Actually, what is it? Floor. Output.edge 0. Something like that. And then we also want... So we're gonna have... I wonder if we can send down something like this. Let's try it. A little bit worried. And I calculate the max progress here in the tessellation shader because we don't want to do it per generated vertex later on in the domain shader. We just want to calculate this once, and then we do this we already do, so what we can do is output dot progress, if we can do it like this, 0 is equal to output dot edge 0 It's a lot of floors and stuff like that, but let's see if this works. 0 minus floor output dot edge 0. Think. Okay, so with all of this, and then we want to do output dot max progress is equal to max something like this. Calculate tessellation amount. We do 2 to the power of whatever that is for the floor. Yeah, let's see if this works or if we get any compiler errors. Okay. Unexpected token. Type mismatch between additional values. Yes. Unexpected token output. I'm worried about this one. Or is it the fact? So first one is text chord 0, or actually first one is text chord 1, 2, 3, 4, and then 5. Not a big fan of sending this much data, but so right now we just do binary. That works. So what we want to add back then is, where do we have it? Here we want to add back input.max progress. Not input, but factors. That's the wrong factor. Is it? Yeah, it is. It's a bit too truncated. What did I screw up? Max progress. Oh. Yeah, the problem I was talking about. We probably want to... So this is... We're getting the wrong factor relative to... Yeah, we might be getting the factors for this one since it's closer to being subdivided to 2 times than this one is to being subdivided 4 times. I think that's the problem we're having. Yeah, when we do this, because... I guess this can be fixed by doing... Output max progress, we don't do it by progress here, we do it by edge, and then we do output.max progress is equal to max progress. Okay, so now it fixed apart from these edge cases here, and hopefully we have the correct variables to fix this. So let's try and do, before we do this shit, we do load max progress is equal to factors max progress this. So if we're at UVX 0, no, it's a UV problem again. I think our X0 is here. It's a little bit wrong. The anyway, we want to do max progress is equal to something. In this case, we want it to be equal to the worst thing here is that we have y tessellation, x tessellation. Maybe this will work. Maybe this will work. Actually, we can do factors dot add progress, and then it's going to be different. So for x is equal to 0, we're going to go with edge 0. And we're going to go with these, I think. So 2, I think 1, 3. That looks hella good. Looks good. It looks fucking beautiful. Looks great. Great. I think we have it. Although a little bit worried about this. The seams look great. The only problem we have is when we get to yeah, of course. This looks beautiful. Apart from extremely close. How does it look with this? I'm pretty sure we have it. Except for this one, of course. So when we zoom in to the center here, since we base it on this point, and this point, we're still far away enough that we're not getting the next. Or it might actually be... Yeah, I know what it is. We're getting closer and closer to the bottom, this corner. But then we start getting further and further away from it. We can even do a move towards this one. That makes me wonder. Did we have this problem previously? Maybe. Ooh. This is not a problem related to this specific problem. This is actually tessellating based on distance to corner points. Could do... what the fuck? We probably want to do... Ooh, we can probably do this. Let's see here. Get closest point on plane and then do the max tessellation based on that. We're still gonna have to do the edges because of this. Huh. Okay, but anyway, we're gonna chunk that up to it's a current problem. We could probably do, if we do tessellation max distance, or minimum distance actually, to be less than one lane. Something like that. I guess it would have to be... Okay, what happens if we disable this one and enable this? Worst case scenario, crash. Hopefully not. Snow tessellation amount max. Let's bring that up. Let's bring the distance up as well. Hmm. I think we can work with this. Although, yeah, we can. Let's see, what do we need to do? Stats. Yeah, we pretty much have max. Quite rough, but okay, let's see. So what do we want to do? If we take a look at this one, we have progress calculated. It feels... we have progress calculated in a very rough way. So it's pretty much... Do we use this one? Yeah, we do. Do we use... No, we don't. All of this basically just calculates the age of a vertex based on... Okay, so this together with whatever the fuck this is calculates, roughly speaking, the age of a vertex in the tessellation life. And what we want to use this one for is to offset. So when we calculate height later on, we want to offset it based on this. Unfortunately, this sucks because we're gonna have to... Actually, that's not entirely true. We do that anyway, I think. We calculate the height of neighboring vertices. So let's take a look at this. Okay, maybe it won't be. So if we have a vertex, we base its normals and height and some other stuff on the neighbors. So these 9 vertices we're always going to recreate, pretty much. We do it by sampling height maps and stuff like that. But if we take this one, for instance, we want to calculate its perfect value, which we're already doing. So P A. And then we want to calculate its P0 position. So that is pretty much if this one's, so if the progress value is 1, that's also P. We can do it like this. So we have real height and we have interpolated height. If progress is equal to 1, then we give it a height, the perfect height. If progress is equal to 0, we give it the interpolated height. In between progress 0 and 1, we interpolate between these two. This one we already have, so we want to calculate this one. This one we calculate by doing, we pretty much interpolate between this point and this point. And take the middle, and then we interpolate between this point and take the middle. Although I wonder, but the normal values, that is, yeah, the normal values I think we want to calculate as if, and we're gonna play around with the normal values as well. But I don't think it's harder than this. And we have already recreated this one and this one and this one and this one. So this is just a question of doing a bilinear interpolation. This one. I think. So here we create the snow vertices. Here we create normals. Position center vs displace. So I guess we can do, let's just do it like this for now. Position center interpolated is equal to interpolate bilinear. Let's go, we can just do this. Snow vertices. 1, 0. Snow vertices 1. Just have to double check so this is the correct one. 1, 2. Snow vertices. Snow vertices 2, 0, 1. Come on. no vertices 2, 1. Float 2, 0.5, 0.5. Let's see here. Interpolate bilinear. P1, 2, P3, 4. Yes. And then if we do displace, we do lerp between position, center interpolated, snow vertices, 1, 1 position world space. Here we do, what did I call this one eventually? We called it... diff... max progress. Current diff we don't use, right? This. Max progress. That's the one we use here. 1 sec. Yeah. And then we can also skip this one. Interpolate bilinear, cannot convert. Oh, yeah. Dot position world space. Okay, now we just need to restart it because our activity texture does not get sent down the correct way when we do hot reload. We still get extreme popping. I might know why, but I wonder. Still get. Do we? See, do I have some new vertices? Actually, let's bring this one down a bit. Eight. So here we get this one as new. Which one is it? This one. I'm not really seeing the result I would like. Here, when we pop in the new ones, these ones, we would like to get them around here. Why don't we? So when we pop them in here. And then as we move closer, we bring them up. What am I missing? It's almost all, it's like max progress is at 1 all the time. Why? Here we can see that we get some movement here. It's just not perfect though. We get popping here. Huh. I want to do, let's do this, exit. Test. Great. Let's do if test is bigger than 0.5, return input dot test. Now we do output dot test is equal to max progress. And then we do test 0.4, or actually let's put it at 1. Yes. So this one we add, we just want to base it on... What the fuck? We just want to... Yeah, we add all new points to edges. So then we need to figure out which edge we add it to, and that's the only points we want. Ooh. Really? This one we add between this point and this point. The good news, we only need to do one interpolation, but we need to figure out which one. So right now for this point, when we add this point, we actually do it for this point, this point, this point, and this point. That's wrong. Is it always diagonal? No, it's not. So for this one, we want to do it for this one and this one. Ooh. Okay. If we can figure this out, I think it's good though, because we're gonna need this probably when we flip quads and stuff like that later on, but... So how would one go about figuring this out? But actually... Now we can do it by... Okay, we can do it in a rough way. Our UVs will tell us. So for this point, for instance, the UV both in the X direction and the Y direction is off. For this one, the UV, only the UV in the y direction is off. Okay, we're gonna do this with an ugly branch for now and see if we can see some pattern. Oof, 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 oof. Okay. So for this one, the UV in the, unfortunately, the y direction is wrong. So then we want to go. So we need to figure out we can probably do it like this. So to direction is equal to so the problem is we have when we interpolate, the directions are a little bit fucked up. So we go upwards in X, here in Y. So let's see if we do something like UVY is not equals to 0.0. And UV.X, X compare value, not equal to 0.0. Is this the direction? I think so. So when we do the interpolation here, we actually just want to do lerp between snow vertices and direction.x, direction.y, but we want to do is 1 plus snow vertices 1 minus direction dot x 1 minus direction y 0.5. Maybe. Although I wonder. We need to differentiate between so for this one we will get 5 new points. It's important that we go in the direction of this cut right here. Negative, that's wrong. I think it's So actually, when we spawn a new one, we can either have it this. So we want to go up in Y, down in Y. See, yeah, something like this. Let's see what kind of result this gives. Lerp. Oh yeah. Session vs. Let's see what we have. Okay, it seems to be a little bit better. Still some brutal popping. Let's see. So in this case, when we spawn, we interpolate those the correct way. When we spawn this one, it's still, oh, we have some that goes like this and some that goes like this. Fuck, that sucks. Okay. At this point, have it working for some, I reckon. Let's disable this one. So yeah, this one still pops, which I find weird. So the point that we spawns here actually starts completely down. And we don't get that one to move. We get some of them to move, but not... I wonder if I mistook... We get these to move. Makes me wonder if direction... By flipping these two were the wrong choice. Possibly, I just want to see what we get if we do. And then I'm a little bit worried about getting the tessellation. So we have some tessellation that goes... The diagonal line varies quite a lot. Not a big fan of that. We still don't have the correct... Actually, it doesn't look too wrong. Let's disable this one. Yeah, the popping is actually mostly because of the... Now it's pretty much the opposite way, isn't it? So this one, for instance, we pop it in, And initially when it's popped in, we lower it and then we heighten it. I think that's because we lower it to be this one. So we want to do the opposite on X and Y. The hard part is going to get these diagonal ones correctly. So yeah, this one, for instance, spawns lowered when it should actually be, let's see here. Trying to make sense out of this. Diagonal one's definitely wrong, but if we take a look at this one, if we subdivide it. Yeah, this one gets the middle point of this one and this one, I think. Actually, the middle point of... Oh... That is true. We're getting the wrong... Yes, I get it. This one actually gets... I get it. This one... actually reads... we would like it to read this one and this one, but in this case I think it reads... no one error we're doing. I'm just trying to figure out if it's the only one or if there's more. We're gonna need some better debugging for this one, so I'm wondering... I think we're gonna do this. Let's see. Let's do this. Disable these. Re-enable this one. Procedural snow terrain. We're gonna add activity texture to the properties so we can set it. And then we can probably set it to terraform brushes. One of these, I reckon. 8. Or maybe we can do noise. Nah, let's do circular. Util terrain activity data. What do we... Terrain activity data. Now we have a little texture here, and let's bring in, let's go 128 times 128. See what we get. So this way we can debug it. We can make changes to it in real time and it will change. Although I wonder. At least that's what I hoped. Displays. Oh yeah, we need to send in one more thing. This one. Then we set that one to be equal to, what do we have? 128, 128. Do we get the correct displacement this time around? No. Ah, we can actually show the activity data. That's good. So why don't we get a displace? Yeah, we need some other stuff as well. We need... We need... Terrain bounds and terrain data value bounds. Environment, what do we have? Terrain data value range 0.5. Zero, 5, and then I guess it's 0 and 10 here. Okay. Problem we're having now is that this one is probably bilinear. Okay, I see. This is thanks to our... Yes, okay. So it's when we add the new vertices, we get this. Go down. Okay. So let's change this one. Let's remove. Let's set max progress to 1. Then we get something like this. Although I'm a little bit... I would have hoped that we would be getting a little bit more of a gradient here. Okay, but I get it. We can do snow height, snow height, snow height. One is max. Snow height. Jesus, how big are we gonna go? Let's do snow height 1. And then we do rain bounce 1, 2, 3, 4, 5, 6, 2. it something like this. Change it a bit as well, so we do turn 4 1 1 1 1. Just want to make this easy to work with. Easier to work with, rather. Yeah, we probably want to go with noise instead. I reckon this. Five. Actually, what we would like here is a... We don't want nice gradients, we want... sharp edges, I think. Because now we have the problem of generating the new vertices in the correct place, simply because that's how our texture looks. It's not really in the correct place though. But it would be nice to have... Yeah, I'm thinking of doing something like... It's 4 times 64. And then we do... Wonder if this is enough. White. Let's see. Displays test. Let's see what this one gives us. Okay, this is way better. Although... yeah, so this test here, for instance. When we add new points here, we want to its base value should be, it should be interpolated quite a lot. We want to do it based on this one and this one. Same with this one. So this one. If we add back max progress here, let's see what we have so far. So for this one, we keep these 4. We add one new here, but it's right at the bottom for some reason. So we add one here, one here, one here, one here, and all of them are at the bottom, except for this one actually, and this one. This one also changes its... no, it doesn't. Okay. And then we add one here, it's at the top. Okay, this is gonna be... it's gonna be a little bit easier to work with here. This one seems to be correct, but it doesn't... this one is correct. This one is not. So my question then is... okay, how can we test this? One thing that we do wrong is when we read the neighboring vertices, we don't actually read the neighboring vertices, we read it, the neighboring pixels in the texture, which could be the cause for one issue. So this one, for instance, I'm wondering if this one reads... because these that spawn in the middle, they are all wrong. No idea why this one is wrong though. Could be because Okay, if this one reads this, it doesn't matter, but for this one, I want to try and do... What kind of result do we get if we flip these again? Same. Okay. So what if we do... When we calculate UV step here, I think we want to do it by compare value and X compare value. It's 0.25. Yeah, we do. So I think we want to do by compare value, X compare value, and then we use UV step here. This one still screws with me. Why do we get... We can do 64 times 64. This looks correct. It's just when we spawn the new ones here, we want to... So this one, instead of popping to this, we should be getting... It should spawn here and fade to this one. So if we do max progress 0, do we get... Why is this one getting... We're moving in the wrong direction. We're reading this value. That's not really true either. Hmm. Point 0.5. This one pretty much just reads its value. Okay, we're gonna jump to oh 0.5 1 here. So we know that we get the correct values here. That's good. It's the 0 values that are fucked. Let's show test 1. This is still correct, yes. So if we take, I just want to see what happens if we take always in the X direction. So we make direction here be equal to, direction is equal to float 2, 1, 0. And then we do max progress here. So this one should read this value and this value. Okay, the final result is great. But then it goes, so if we're at 0.5, but then we go even more. That's very weird. Right about here is this value gets calculated the wrong way. I think we're close to solving it, but fortunately I won't have much more time to try it today. But we can see here, when we do the flip, this one goes way too far down. Instead, we would like to have it around here, right? We would like to have it here. But then it slowly but surely gets to its correct position. So that's cool. But yeah, I'm gonna have to quit here. But still solved one problem. Got to another one that is equally hard. Yeah, thank you so much for watching and have a great weekend. Peace.